Hi guys! Welcome sa ating video series ng Thermodynamics. So dito sa series na to, pag-uusapan natin yung concept ng Thermodynamics and we will be solving different problems galing sa iba't ibang textbooks. And dito sa video na to, pag-uusapan natin kung ano ba yung Thermodynamics, ano yung mga applications niya, at ano ba yung mga books na marerecommend namin para matulungan kayo sa inyong studies. And sa last part ng video na to, pag-uusapan natin kung ano yung pinagkaiba ng thermodynamics sa heat transfer. Dahil maraming nalilito kung ano ba yung pagkakaiba nilang dalawa. Well, pag-usapan muna natin kung ano ba yung thermodynamics. Thermodynamics is the science of energy. It is the study of energy, including the conversion of energy from one form into another and the effects that adding or removing energy have on a system. Thermodynamics came from two Greek words, therme meaning heat and dynamis meaning power. Well, this name is the most descriptive of the early efforts to convert energy to power. And today, the name thermodynamics is broadly interpreted to include all aspects of energy and energy transformation. Well, in chemical engineering, the principles of thermodynamics have a fundamental role in how chemical processes are understood, analyzed, and designed. It is also important to understood na in our studies for thermodynamics, meron tayong 4 na law of thermodynamics na pag-aaralan. Meron tayong tinatawag na zeroth law, the first law of thermodynamics which is the law of conservation of energy, the second law of thermodynamics which is the law of increased entropy, and the third law of thermodynamics which states that a perfect crystalline structure at absolute zero temperature will have zero disorder or entropy. Well, sa mga succeeding videos natin, pag-uusapan natin kung ano-ano ba itong mga laws of thermodynamics and we will be solving problems related to this law para mas maintindihan natin siya. Now, what are the applications of thermodynamics? Applications of thermodynamics are found in many fields including but not limited to the following: power plants, internal combustion engines, refrigerators, air conditioners, fuel cells, and a lot more. Well, kung mapapansin natin dito sa lahat ng example natin, all of these devices make use of heat to achieve useful work and vice versa. So, ano-anong mga books ang aming nire-recommend para mabasa ninyo and to aid you sa inyong studies for thermodynamics? Well, maraming books in thermodynamics but these are the most popular sa iba't ibang engineering fields. We have the Advanced Engineering Thermodynamics by Adrian Bejan. We also have the Thermodynamics and Engineering Approach by Siegel, and the Fundamentals of Engineering Thermodynamics by Moran. Others are also using the Engineering Thermodynamics by P.K. Nag. And para naman sa ating mga chemical engineers, we are using the Introduction to Chemical Engineering Thermodynamics by Smith and Van Ness. Well, as I said, there are many books of thermodynamics available in the market. Dahil halos lahat ng engineering fields are studying thermodynamics. Okay, so one of the question na lagi na itatanong is, ano ba yung pinagkaiba ng thermodynamics at heat transfer? In fact, maraming engineering interviews are asking these questions. Kaya mahalaga na mapag-usapan natin to. Maraming nako-confuse dito dahil it seems merong pagkakapareho yung thermodynamics at heat transfer. So, it seems meron siyang pagkakapareho. So, pag-usapan natin yung pinagkaiba nila. Thermodynamics deals with equilibrium states and changes from one equilibrium state to another. So, let's say meron tayong graph and meron tayong equilibrium state 1 at nag-change siya to equilibrium state 2. So, itong state 1 natin nasa equilibrium state at ito namang state 2 is nasa equilibrium state din. So, from this case, magagawa nating ma-determine yung amount of work and heat transferred from equilibrium state 1 to equilibrium state 2 through thermodynamics na may unit na joule. Pero, hindi pinag-uusapan sa thermodynamics kung gaano katagal nangyari yung process na yon. So, hindi concern ang thermodynamics how long the process will take. While in heat transfer, we are discussing about the heat transfer rate, which is in joules per second. Also, thermodynamics is not worry how the system has changed from equilibrium state 1 to equilibrium state 2. So, hindi natin pinag-uusapan sa thermodynamics yung mode ng transfer ng heat. Paano nangyari yon? Samantalang sa heat transfer, pinag-uusapan natin yung modes of heat transfer such as conduction, convection, and radiation. So magbigay tayo ng analogy para madali natin siya maintindihan. Suppose you are traveling from Manila to Tacloban. So yung distance na tinravel mo, distance S, is analogous to the amount of heat or work in joule. Dahil mami-measure mo yung distance na na-travel mo from Manila to Tacloban, the same way naman sa heat. From equilibrium state 1, dito ang equilibrium state 1 natin is Manila, at ang equilibrium state 2 naman natin is yung Tacloban. So, nami-measure natin yung distance na tinravel, and of course, mami-measure din natin yung amount of heat. How about yung speed, distance over time? Analogous naman siya sa rate of heat transfer. So, kung gaano mo kabilis narating yung Tacloban from Manila, sa rate of heat transfer naman, makikita natin kung gaano kabilis narating natin from equilibrium state 1 to equilibrium state 2. Ngayon naman, paano ka nakarating sa Tacloban? Naglakad ka ba? Nag-land travel? Nag-eroplano? Or nagbarko? Yan naman yung may kukumpara natin sa modes of heat transfer. Why there is a need to undertake a detailed study on heat transfer? Knowing the fact na makukuha naman natin yung amount of heat using thermodynamics alone, bakit kailangan pa natin pag-aralan yung heat transfer? Well, in practice, we are more concerned about the rate of heat transfer, the heat transfer per unit time, than we are with the amount of heat. For example, itong hot coffee na nasa loob ng thermos bottle. Alam natin na eventually lalamig yung hot coffee na nasa loob. Let's say, nag-drop yung temperature from 90 degrees Celsius to 80 degrees Celsius. So, using thermodynamics alone, makukuha natin yung amount of heat transferred. Pero, for the typical user ng thermos bottle or sa designer ng thermos bottle, we are concerned how long does it take for the temperature to drop. Dahil kung tayo magde-design, ang gusto natin na yung hot coffee na nasa loob ng thermos bottle ay matagal na lumamig. Determining the rates of heat transfer to or from a system and thus the times of cooling or heating as well as the variation of the temperature is the subject of heat transfer. Take note din natin, ang thermodynamics is an equilibrium phenomenon. It deals with equilibrium states and changes from one equilibrium state to another, while yung heat transfer naman deals with a system that lack thermal equilibrium. So it is a non-equilibrium phenomenon. Therefore, the study of heat transfer cannot be based on the principles of thermodynamics alone. However, the laws of thermodynamics lay the framework for the science of heat transfer. The basic requirement of heat transfer is the presence of a temperature difference. The temperature difference is the driving force of the heat transfer.
Well, that's it for now, guys, and thank you for watching. We would like to ask for your support by subscribing sa aming YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na pinopost namin. We are also inviting you to register sa aming website www.engineers.org. It is an online community for Filipino engineers, engineering students, and STEM students. Well, thank you very much and have a nice day.